And so today we talk about extinction, which sounds kind of grim, but actually, extinction isn't all bad. It allows for new species to develop. So let's take a look at extinction throughout geologic history. It's estimated that Earth has about 5 to 30 million species of plants and animals. Only about 2 million species of these have been described. The number of species of the really primitive things, the bacteria and the archaea, probably greatly exceeds those of the plants and animals we normally think about. Furthermore, billions of species have evolved and become extinct over the Earth's 4 billion years of history of life. So what is extinction? Well, it's best thought of in light of... So, how do species develop and what is extinction? We're going to take a look at speciation and extinction. Speciation is common, extinction is common. Speciation is the development through evolution of a new species, and new species develop all the time, and on an average they live a few million years, anywhere from 1 to 11 million years. The average longevity of mammal species is about 2 million years, and coincidentally, by the way, humans are about 2 million years old. And there is an overall increase in the diversity in the number of species over time. So this graph shows you some of those characteristics. It shows you the number of different genera since the start of the Cambrian about 540 some million years ago. And you can see that the number of species or genera increases and then suddenly drops, increases and drops. Increases, stays steady, and drops. Increases and drops, increases again. There have been, in fact, throughout geologic time, 5 times that geologists identify as mass extinctions. So extinction is normal, it happens all the time at a background rate, but mass extinction is the extinction of at least 50% of all species on Earth at the same time. And the 5 mass extinctions in Earth's history are shown here in the blue circles, and they are the late Ordovician extinction, where about 55% of all species died off, the late Devonian extinction, with about 70% of all species lost. The Permian extinction is the largest by far. More than 90% of all living species were made extinct at the end of the Permian. The Triassic-Jurassic extinction, just a little bit later, 70 to 75% of species extinction. And then, of course, the one that everybody knows most about, the Cretaceous-Tertiary extinction, where 85% of all species went extinct, including all the dinosaurs. Now, the largest mass extinction was at the end of the Permian, and at this time, 90% of all species became extinct. And there have been several ideas about what might have caused this. Lack of oxygen in the oceans, massive amount of volcanic eruption, a comet impact. Nobody's really been able to come up with a definitive answer for the reason or the cause of this extinction at the end of the Permian. But it also marks the end of the Paleozoic period and the beginning of the Mesozoic. In the ecological niches left behind, more complex animals evolved rather quickly. The Cretaceous-Tertiary mass extinction at the end of the Cretaceous period and at the end of the Mesozoic, therefore, and the beginning of the Cenozoic is the most famous of all, and we know that that one was formed by a meteor impact. So how do we know that? There's actually a great deal of evidence. A large asteroid came down and hit Earth. Actually, it landed in the Gulf of Mexico, pretty close to Mexico, and the crater has been found at a site called Chicxulub. So what do scientists see that give them the idea that a meteor might have struck and made them go looking for it? Well, this is kind of an interesting story of collaboration between a father and son, actually. Luis Alvarez was a physicist and a Nobel Prize winner, and his son Walter Alvarez is a geologist. And in 1980, they were discussing extinctions, and Walter happened to mention that he thought that around Earth, what in his observations, that there was this unexpected increase in the amount of iridium in the soil right at the boundary between the Cretaceous and the Tertiary. And so they got to talking about where the iridium might have come from and started to look at where it was common. And it turns out iridium is a very rare element on Earth, but it's quite common in stony, it's quite common in iron meteorites. And so the theory was developed that perhaps a large meteorite struck, burned up, put a lot of iridium and other dust in the atmosphere. That dust settled out all over the world over time, but it was in the atmosphere long enough to block the sun, to stop the photosynthetic plants, to therefore kill a lot of the animals and cause a giant mass extinction. And it turns out that all evidence that has been proposed and sought and found about the KT boundary supports the theory of a large asteroid impact, including finding the asteroid impact site. And here's the site of the impact in the Gulf of Mexico at Chicxulub crater. In this area, minerals show evidence of shock, and they actually show evidence of shock a fair distance away. There's melted rock, which we call tektites. There are tsunami deposits by the yellow triangles all over the North America and the surrounding islands, and the crater itself was discovered in 1990. So this is the youngest mass extinction. It is therefore the one where the most evidence still exists, because remember, our Earth is constantly recycling itself. So the older you get, the fewer samples you have of that age. And that's one of the reasons why we have a pretty definitive answer on what caused the KT boundary extinction. Now, some people say that we are in the midst of the sixth mass extinction, and that life is quite threatened, mostly by the actions of man. This graphic is from the New York Times, and it shows for different families of animals the number of species that are threatened or not threatened. Notice you might already know that the frogs are in deep trouble. 41% of frogs are in threatened state today. The bottom half of this New York Times page shows more categories of flora and fauna that are under threat for extinction, including flowering plants, which are looking pretty grim right now, and fishes and reptiles and mollusks. So what do you think? Are we in the midst of the sixth mass extinction?